All right, everyone, welcome to CECS 211, Principles of Engineering 1. Now, I find that name is just slightly misleading. Principles of Engineering 1, it's very vague, abstract. What are we talking about? So in this class, we're going to be dealing with circuits. This is the first introductory class that we have in our program for dealing with circuits and circuit components and things like resistors and current and voltages and all those things that are the basis of how computers can even work in the first place. So everyone's taken 201, correct? Or at least is currently taking 201. When you're dealing with digital, you are much more abstracted from the electronics you're talking about at the gate level, and you're talking about ones and zeros. Analog electronics, resistors, current, and voltage, that is all a little lower level. It is below that. Okay, so that's what we're going to be dealing with in this class and building upon that foundation, and then leading into the next class, which is 311, which hopefully for everyone here would be next semester, at which point you get into a lot more of the applications. So this is a circuits class. We're dealing a lot more with circuit analysis techniques, drawing schematics, how the fundamentals of electricity work. So the first place that I want to point everyone to is the website for class. Okay, I'm going to type this one into chat. Okay, it is www.engreric.com. So let's go ahead, let's head over to the website. Once you get there, you'll be greeted by this screen. Now, this page is my own personal website. I put all class content as well as recorded lecture videos on this website. So this is going to be where all materials for class are held. I don't use Beachboard for that. Beachboard I use for grades, I use for submissions, specifically like Dropbox for turning in assignments, and I also use it for quizzes and exams. But I don't use it for dissemination of materials relevant to class. I keep all of that organized on the website because I just have more control over that, and I don't have to, redo it every semester. So I like for things to kind of stay here and sort of lives and breathes and evolves and gets better. Plus, I can add all sorts of extras, and things are just permanently there for anyone to see at any time. So once you come over to the website, you'll see all the classes that I teach are linked over on the left-hand side. So let's go ahead, let's go over to this class, CECS 211. Okay. CECS 211, Principles of Engineering or Principles of Computer Engineering 1. Like I said, this is really a circuits class. And the first link over here is the syllabus. So go ahead and open the syllabus and follow along. Now, before I start diving down this syllabus and let me go ahead. Let me do an introduction of myself first, and then I'll get to the next most important thing. Okay, first off, my name is Eric Hernandez. I've been teaching here at Cal State for about 7 years now. I teach a lot of the computer engineering related classes, 211, 311, your senior design classes, 490A, 490B. What else I've taught? I teach 262. I've taught 346, 347 in the past. I'm a computer engineer at heart. I love computer engineering, and I'll try to stay in the computer engineering classes as much as possible. Now, let me go ahead and dive into what I think is one of the most important aspects for taking this class online. Before I go over any of this stuff, I want to point out that in my grading plan, item number 4, I have listed for weekly submitted notes. One of the most important things for taking this class online for you guys that are sitting at home watching this is actively being engaged with the lecture, being engaged with the material. And in my opinion, the best way and the only way to do that is to actively be taking notes, whether that's digitally or whether that's on paper, pencil and pen, marker, whatever your weapon of choice is. Whatever it is that you're using to take notes as you're following along and learning. I have to do that to this day, regardless of, what the topic is. If I'm trying to learn something new, I have to be watching what they're doing. I have to be doing the hand motion, taking notes, asking those questions, and jumping back and forth before I begin to even learn something. So I'm going to be collecting those once a week. You have to submit your weekly notes, including both lecture days. Usually we have 2 lecture days, 2 days of lecture and lab. Now, I talk a little bit about this section. If you notice, it's worth 15% of your grade. So just for taking notes, I'm giving you 15% of your grade. So as long as your notes are reasonable and they're mostly complete, you'll be getting full credit. And that's a free 15% in the class, which I think is awesome for doing something that you should already be doing. If we go down to the section where I talk about the weekly submitted notes, basically things that I already said. However, notice that regardless of the method that you use for taking your notes, they should be converted to PDF, one PDF document, and uploaded to the Beachboard Dropbox. Okay, and over here, if the class is a Tuesday, Thursday, Monday, Wednesday class, then those weekly notes are submitted on Friday by 11:59 p.m. the latest. If it's a Friday class, which this is not, then I would give you till Sunday to turn those in. But for everyone right now, I say this very early in the class so that you can start taking your notes right now. So if you need to grab some paper, if you need to grab some pens, pencils, whatever it is, however you're going to take notes, then go ahead and start doing that now. Because the things that I cover in the syllabus, you're going to forget right after class. Okay, and so I'm going to expect to see those notes that you took today while we're talking about the syllabus submitted on Friday. So I'll give you 30 seconds to a minute right now to go grab some paper. Okay, and while you're taking your notes, to keep in mind is that the whole purpose of this is for each person to be taking their own set of notes. This means you cannot have one person take notes for a group of 5 students or for 10 people and everyone submit the same thing. That's going to be considered plagiarism. That's going to be considered cheating. Okay, everyone's got to take their own notes and submit them on an individual basis. So somebody's asking a good question. Just to clarify, you want us to take notes regarding the syllabus or when we dive into the actual course material. Start taking them now. So I'm going to be covering aspects in the syllabus as far as materials that we're going to be getting for lab. Maybe policies for the class. But most importantly, probably the materials that you're going to have to get for the lab. I want everyone to take notes on what you need to get and by when, okay? Okay, so now that part's out of the way, let's move on to all the rest of the usual syllabus stuff. All right, office hours. Tuesday, Thursday, 12:30 to 1:30 p.m. are my official I'm available hours. Now, what I would appreciate is that regardless, anytime you want to come to office hours, shoot me an email. That way I know somebody's might be waiting for me. There's times where I may have Zoom open kind of off to the side and I'm doing other work and I miss that somebody has popped in. So it would be nice, not necessary, but always nice. Shoot me an email that you are coming to office hours so that I'm, prepared and on board. Okay. Now, it's going to be the same Zoom link as what we're using for class. So the same link that you use to get here is the same link for my office hours, which are on Tuesday, Thursday, 12:30 to 1:30. And also, if those times don't work for you, I can be available by appointment. So no reason to not be able to get a hold of me. Okay, my email address, I'm going to stick to trying to use the CSULB official email address this semester. I am new I should be new for everyone here. But for my other classes, previous semesters, I've tried using my other Gmail account. And I think just out of keeping everything in one place, I'm going to stick to just using my CSULB email address for school-related stuff. So this is where you can reach me. Okay, course website. It's how we got here in the first place. So the link's in the syllabus, but you have to have the link for the website in order to get to the page that holds the syllabus that has the, whatever. So website address gets you everything. Okay, lecture lab, we're meeting at 9:30 a.m. And this will be running on till 11:45 a.m. And it is always going to be on Zoom. Now, this brings me to my next point. All of this stuff's a little superfluous, but a note on this online format. Being that we are online, this is going to be considered a synchronous class. By that, I mean that even though we're online, even though I have some materials posted on the website, and I also have lecture videos posted on the website, that is not an excuse to miss class. Okay, just because there are lecture videos from a previous semester does not mean I get to tune out during this synchronous online portion and just watch the lecture and think that I'm going to be up to speed, because things that I say will not necessarily match 100% with pre-recorded lectures. And believe me, it's a lot of work to upload those, to process those, to put them onto YouTube, to incorporate links onto my website. I'm not going to be doing that every semester. So each lecture video that's already up there is not going to reflect 100% of what goes on in our class. So it is vital, it is important, it is necessary to actually come to the class that we agreed on. I agreed to teach it at this time and you guys agreed to come to it at this time, okay? So please don't skip out on class. Okay, and we are all responsible for this time from 9:30 to 11:45 Tuesdays and Thursdays. Okay, the Zoom link to get here is always available in Beachboard. Once you log into Beachboard and you click on the 211 page, there's a Zoom link at the top that always gets you here to my Zoom course, but the link never changes, and that's the same link for office hours with me. So you can always save that link, and it's the same link for all of my classes as well as all of my office hours. Okay, just a brief overview of kind of what we're doing here. We're going to be talking about electrical circuits. We're going to be talking about devices, components, circuit elements. We're going to be talking about schematics, those drawings that you connect everything up, and how that all works. We're going to be talking about different analysis techniques, and we will be trying to go into as much application as we can for kind of these basics of electronics. One way I like to describe this course: think about math. Think about how you learn to add, you learn to subtract, you learn to multiply, you learn to divide, and you spend a lot of time learning how to do those things, but you don't see how it's applicable. And then after a few years of doing that, all of a sudden you start to realize, oh, hey, this is applicable. This does make sense. This is useful for doing, whatever work it is with those basic rules of math. The same thing is true for electronics. It is hard to talk about the application and how you actually do things with electronics if you haven't learned the fundamentals of adding, subtracting, multiplying, and dividing, right? So we have to walk and crawl before we can run. So a lot of this class 211 is actually just learning those basic rules and basic things for electronics so that we can have a language to then use to do useful things. So I have to say 311 is a bit more practical. 211 is a lot of the fundamentals and building blocks. Okay, I will try to keep it as practical as I can, but it is hard when you are just trying to learn all those basics: Kirchhoff's voltage law, Ohm's law, Kirchhoff's current law, Thevenin equivalent circuits, etc., 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 mesh analysis, phasors, yada, yada, yada. Okay? Okay, let me go ahead, jump over to the textbook that we are using. We're going to be using Grob's Basic Electronics. Officially, I'm going to be sticking with the 12th edition. Any assignments that I give are going to be from the 12th edition. Let me go ahead and pull up what this book looks like. Here it is. Okay. I've played around with a few different books, and in talking to a few of the older electrical engineers, asking them, hey, what do you think is the best book for an introduction and even a 311 for electronics? They all suggested this book. This book comes up a lot. I took a look at it. I really liked it. So I'm sticking with this book for this class. I think it is very practical. It stays away from the heavy involved calculus, differential equations based electronics that I think the electrical engineering department should go into at that medium student level, right? So they're the ones that are going to dive into the heavy differential equations aspects of electronics. That being said, we only have 2 semesters of an electronics class in order to get some useful experience with electronics that is directly applicable to our field of computer engineering. So we just don't have the time or the classes to be able to dive that heavy into the underlying theory. And believe me, it's already hard enough with what we're going into. So this book does a really good job of keeping it in the practical realm of electronics without getting too theory based. Okay, so hopefully that's a good thing for most of us. Okay, as far as the book, you should get it. I don't care what edition you have. However, I will be sticking to the 12th edition. So that's on you if you have a different edition of the book and you're going to go ahead and try and match up. And, I'm not keeping track of what pages mean what in multiple editions. That's on you. Okay. Other things. We're going to need some software to do some modeling of these circuits. The software package I'm using is LT-Spice. This is free software that is available and made by Linear Technologies. They're one of the big vendors out there of semiconductors, of chips, of integrated circuits. And Linear Technologies made LT-Spice. It's built off of an engine called Spice that was developed at Berkeley for doing circuit modeling, and they kind of packaged it. Now, when you see LT-Spice, it looks like it's pretty bare bones, but it is very powerful, believe me. Now, you can get that for free. And you can get it from Linear Technologies. There's no sign up or anything. You just go over there and download it. That being said, go to my website. It's available for download off of the 211 page. And here's the reason why you want to get my version is because I have created components in LT-Spice that we will specifically be using. So if you get the one from Linear Technologies, it's going to be missing things that we will be using. Okay, so you have to get the version from my website. Let me show you where that is. If I go back over to my web page, right here, Tools, LT-Spice. Now, when you download this, you'll be downloading a zip file. You need to decompress that zip file, okay? Zip file just compresses multiple files into one. If you just simply double click, Windows will give you a browser listing of the files inside. It will not actively decompress those files, okay? So you can't just double click on the zip file when you download it and then run the executable and expect it to work. You need to actually uncompress it. And we will be doing this in a future lab, probably next lab, where we work with this in a little more detail. But if you want to get a head start on it, download the zip file, make sure to decompress it, right click, drag to a clear part of your screen, let go. It'll ask you if you want to zip, uncompress, whatever. Go ahead and do that. And then you can go ahead, open up that folder, run the executable, and you'll be able to play around with the circuit modeling software. Most important part, get that from my website. Okay, I will not be running support for Macintosh versions or Linux versions. If you are a Linux penguin yourself, then just so you know, LT-Spice runs beautifully under Wine. I use Wine all the time to run LT-Spice, and it does a great job. So if you're a Linux penguin, go ahead and you can do that route. If you are a Mac user, I have a little bit of bad news. Every class in our department uses some type of software for computer engineering, and very few of them have Mac versions, okay? You're gonna make life much easier starting now if you just use a Windows virtual machine to do that under under Mac, right? So you're in the Mac environment, you run some virtualized Windows software, and then you're able to run Windows applications on that. So many classes you're running, Xilinx or certain types of compilers, or especially your embedded systems classes like 346, 347, 447, those are Windows exclusive apps. So I'm not a diehard Windows. I don't really like Windows that much. I think in recent times they've gone a little downhill in my opinion. I just come from kind of being a Windows power user for many years. There is familiarity. I do admit to that, and I am more comfortable in Windows than I am in Mac. But also just the state of software in general for computer engineering is a bit Windows centric as well as Linux centric. Okay, so that takes care of the software. Let's go back to the syllabus. Okay, I will talk about lab supplies in a little bit. I'm going to save that for the very end. Copyright notice. I'm producing a lot of content these days. I'm almost like turning into a streamer over here. And so I'm just saying that all of my work is my own work, right? I put in time for doing this. So I would appreciate if people do not take my material and then give it out to other people. That being said, all my material is available on my website, so you can get it from the source, right? Just do me a favor and don't just start giving away all my material, especially on Chegg, that kind of thing. Okay, let's get to the grading plan. As far as what's being graded for this class, I already talked about the weekly submitted notes, which you should already be taking. There is a midterm, a final exam. Those are the two big exams for this class. The midterm will be happening sometime around week 7 or 8 of the semester, and I will let you know at least a week in advance when the official date for the exam will be. All exams will take place on Beachboard, so I'll talk more about those exams as we get there. One thing to know about these exams is all the preparatory material to get ready for those exams is already available on the website. So if I go back over to the website and scroll down here, you can see I already have a midterm prep section with pages out of the book. I have a sample midterm 1 with solution, the topics that would be on this exam. So no need to download the version that's already on Chegg because I already put it on my website. So I don't understand why it's there as well. But here's the midterm. Okay, for the final would probably come, okay, over here there's final exam prep. It is cumulative. About 2/3 of the material on the final would be new, and 1/3 would be pre-midterm pre-midterm. There's only 2 exams in this class, 1 midterm and 1 final. So even though it shows here that there's a midterm 2, just so you know, in the syllabus, that's the one that matters. There's a midterm and a final. Those are the only 2 exams. Okay, so all of that is already available there. Okay, do I have any questions about the exams before I move on to the other aspects of grading?
I have a question.
Yeah, what's up?
That midterm 2, if we wanted to study that, would that be more for like midterm 1 or the final?
Yeah, that's a good question. So probably, let's say like the first third of midterm 2 would actually be for the first midterm that you guys are having, that we are having. And then the later half of midterm 2 would be for the final.
Okay, thank you.
Yeah, in the past, and this is the reason why it's like that on the website. For one thing, I'm lazy and I don't feel like changing it. I already gave out those materials and the problems haven't changed. But at the same time, I used to do 2 midterms and 1 final. And for the online section, I've changed it to 1 midterm and 1 final. So that's why it's like that on the website. But yeah, good question. Anything else in regards to the midterm final? Okay, let's move on to labs and homework. There will be labs. We have a labs section, and we will be, for the very beginning of class, we're going to be doing a little bit of lecturing during the lab time. I'm sorry. Also, we'll be doing some simulation, and then it's going to get into a lot more of the hands-on stuff once we get our equipment. So I'm excited to get to that part, talking about the supplies and what we're going to be doing. I'll get there once we're done with the syllabus. Okay, and homework is lumped into here. There's not that much homework that I plan on collecting, but just in case there is, I'm lumping it into here. Weekly submitted notes, already talked about that one. Notice that the late homework, late work that I'm collecting like this is going to be losing 10% per day, not per class meeting. So if you think like, oh, it's due on Thursday and I'm going to turn it in next Tuesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday. Was that 5 or 4? Did I start with this finger or did I start with this one? It's a good question. Thursday, Friday, Saturday, Sunday, Monday, 5. Yeah. Okay. So that's 50% already. Okay. So it's important, if you are going to be late, make sure you're turning it in somehow by, the next day so that you're only losing 10%. Okay. Weekly submitted notes. I'm not planning on collecting late submissions for the weekly submitted notes. It's just going to create more work for a lot of stuff that I have coming in. But just so you know, the weekly submitted notes, hugely important for you to doing well in this class. And it's not even about the grade. If it's mostly there, I'm going to be giving full credit for that. If it's not plagiarized and not copied, the worst thing you could do is take pictures of somebody else's notes and then submit them as your own. And I'll tell you right now, if that happens, if I find that one person did notes and another person just took pictures and submitted it, both people involved plagiarizing, both people are copying work, that's going to be a 0 on that assignment, 1 full letter reduction grade of your final grade. So if you ended up with a C in class, that's going to be a D. So it's not even worth doing that, okay? Please. That goes for all assignments. Okay, but if I find, especially in the beginning, this is a big class. If I see that a few people are not submitting those notes, it's not really about that grade. I'm going to ask you guys to come over to my office hours, and we're going to talk about what's going on, because we cannot fall off. I had this happen last semester, and please, who's got their microphone on? Okay, I had this happen last semester where people were just falling off. Everything was great. Everyone was saying everything was good. Halfway through the semester, all of a sudden, people are tuning out. People are logging into Zoom and then grabbing breakfast or going and doing other things. We can't do that. I need everyone actually engaged with the material, taking notes. That's the most important thing to me. And that's the whole purpose behind me asking and requiring that everyone needs to submit their notes. Okay. Quizzes, participation, and attendance. This is a 10% of the grading plan category. Quizzes may or may not be announced beforehand. So I'll put it this way. If the quiz is elaborate, I probably will be giving notification about it. But a pop quiz, it will probably be simpler, okay? And I can have a quiz on Beachboard through the quiz system, just like I would do an exam, or I might actually just say something during the lecture and ask everyone to email me something, okay? At which point I can just do a pop quiz within seconds here. Everyone's got to email me the answer, and then that's the quiz. Okay? That being said, the quizzes are only 10% of the final grade. So a bad grade on a quiz is not meant to hurt your grade. I also will be dropping the lowest quiz. Okay, so the quiz is really just more of a tool for me to not only help with participation, but also to help you guys have an idea of questions that may be on the exam. I do a lot of, hey, here's a quiz, and then here's that same question on an exam. Okay? All right, as far as grading, here's how I do this. I enter in all grades as is into Beachboard. Like I said, I use Beachboard for the grades, for the grade book, so you guys can see that. I also use Beachboard for the quizzes. And I use Beachboard for the Dropbox. Those are the main parts that I use Beachboard for. As far as the grading goes, I enter in the grades as is, unadjusted, uncurved. At the end of the semester, once all grades are in, I will go ahead and curve, but only once at the end of the semester. Okay, so just so that everyone knows, you may see that your grade is like at an 87 and you're just like, I thought I was doing really well and I should be at an A. You probably are, it's just I haven't curved the class yet, okay? So I'll do my best when big items like midterms, like when the midterm happens, of giving everyone an idea of what the curving or adjustment to the grade looks like so that you can have a better idea of what your final grade in the class is. That doesn't mean I'm entering in any of these grades as curved. I will curve only once after the final. Okay. Great question. Do we submit weekly notes through Dropbox? Yes. Let me go ahead and show you what the Dropbox looks like right now. Okay, so notice there's the equipment loan agreement, which I am about to talk about in a couple of minutes, and then lecture notes week 1, lecture notes week 2, lecture notes week 3. I do have a list of dates for these. I'll put them up on the website, but just so you know, this is week 1. So week 1, this Friday, is when the first set of lecture notes is due. Next week will be week 2, and so forth. Okay, so one PDF with 2 days of notes. That's what I'm looking for. So today's lab and lecture, and Thursday's lab and lecture, all in one PDF posted into this Dropbox on Beachboard. And like I said, if it's handwritten notes, you are welcome to just take a picture of your own notes and put them into a PDF and upload them that way. Or if they're already in, I don't know, if you're doing it in Word, I guess, or some other digital format, however you get that into a PDF, one PDF, and then upload that is fine. Okay. Do you have an estimation of how much your grade will change at the end of the semester, or an explanation on how you're going to curve? Okay. Yeah, sure. I can do both. Okay. Generally speaking, between 5 to 10% is curved. However, I've never collected lecture notes before, and that's 15% of the grade. So it is possible that I may not even have to apply much of a curve at all to the class because of that extra 10 to 15% that people are just getting from freebie points from taking and turning in notes, which you should be doing already. So this really is a win for you guys. Okay, how do I curve? I'll tell you exactly. I take the top 2, 3, 4 people. I average them together and I look at how far away they are from a good solid A, like a 95 to 97%. They may be 5 points away. So I go ahead, I give them the 5 points, I make them all A's, and I give that same 5 points to everyone. That's a linear adjustment. So I start off by doing an average of the top 3 to 4 and then linearly adjusting the entire class by that same amount. Then I start going down the list and I start looking for gaps. So if I see a big gap just below the B to C category, I just bump everyone up so that that gap falls into the B to C distinction, right? What I'm trying to avoid is all of the 79%, can I have a B? Yes, you can, okay? If you're at 79.4, you should be getting a B. I don't want to deal with that. So I'm looking for a nice, good 2 to 3 point gap just below the B to C distinction to move everyone up. And then I do that for the C to D and so forth, right? But remember, I start with that linear adjustment of everyone. So that's how I do my curving. It starts with a linear, not so much curve, and then it turns into a curve as I try to push more people into the BC range. I think if you ask any student that's had me before, they're going to tell you that I'm fairly fair when it comes to grading. I haven't had anyone dispute a grade with me yet. Except when they saw the unadjusted one and then they're already sending me an angry email and I'm like, dude, I haven't even curved yet. Like, give me a break. Okay, so that answers that question in chat. Any other questions? Okay, let's go ahead. Let's finish this up. I still have to do roll, lab supplies, and I want to use the lab time in order to get into a couple of things. Midterm, final exam, labs, homework, weekly submitted notes, quizzes, participation, attendance. I already talked about all of these. If you have any questions, chat. Exam assignment makeup policy. Okay, this does happen. Usually a couple of people don't end up coming to a midterm and then ask me later for a makeup. Here's the answer to that question right now. There are 2 types of absences you may have. An absence that requires advanced notification and an absence that does not require advanced notification. Advanced notification is like, I'm going to be at a school function, like an athletic thing. You know about that beforehand. I should know about that at least 1 week in advance. Also, religious reasons, jury duty, things like that would be under advanced notification. Things that are not anticipated, emergencies, sickness, illness, death of an immediate family member, things like that. Okay. Now here's the deal. When it comes to those emergencies, let me know as soon as you can as to what's going on so I can just work with you. And we can go ahead and do a makeup. Now, for any type of emergency, there is a requirement of documentation of the emergency. So if it's like a medical thing, doctor's note. If this is a vehicle type accident, then accident report, things like that. Okay, so I can go ahead and do a makeup for any good reason as long as we have some documentation of that. Okay. And this is taken directly from the university policy. You can go ahead, check out the link from here as to what they say. It is almost an exact copy of what I have here. Then we get over to that cheating, plagiarism, academic integrity thing that I already mentioned about. Not submitting other people's labs or homework or other people's notes. Those are the big ones that at least I'll be able to see right away. The other ones is, well, Discord during an exam. How much can I do about that? I don't know. Okay. This is also taken from Cal State's website. You can check on their cheating and plagiarism plan. We have a zero tolerance policy in the department, and it has been a problem in the department across all classes. And that is something that everyone's been talking about behind the scenes, which is that there's so much copying and cheating going on. Okay. And I think you're going to see a lot more strictness in terms of this policy. So please be on the lookout for it. Be careful. If there is proven cheating, copying, stuff like that, it is 0 credit for the assignment in question. And whatever your final grade is in the class is a full letter grade reduction. So it's not just that you would get a 0 on an assignment or on an exam. You would also, if you got a B in the class, you would now be getting a C. Here's the other thing that is not mentioned here that was talked about in the department meeting last week, which is that there will also be notification to the school as to the cheating in question, and it is very likely that they can and will remove your ability to do a repeat delete on the class. So what does that mean? If your C turned into a D, then you're going to be stuck with that D on your GPA because you will not have the ability to replace that D with a B or an A later on. Okay, so you may also be losing the privilege of doing a repeat delete. And if you don't know what the repeat delete policy is, you should. It's awesome. If you get an F in a class, you can retake it the next semester and turn that F into an A. And it doesn't affect your GPA, okay? It's a sweet deal for when you had a class that went horribly wrong. But if there is cheating and it gets reported to the school, it's very possible to lose that. Okay, I have a tentative schedule of what's going on so you can kind of see the roadmap of our topics and where we're headed. A better place for this would actually just be to go to the website. And I'm going to show you something. The lecture videos page. I have one of these for every single one of my classes. If you go ahead and click on that, I have lecture, 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 lecture. There's so much video content here. Okay, so if you're curious about what we're doing next week, if you're curious about what happened last class, this is going to be your number one resource. However, it is not a replacement for class. Like I said, synchronous. We're here today, and we're going to be responsible for this time. Prerequisites. How many people need to add this class? Say it in chat right now. You need to add this class. The screen didn't freeze. I'm just waiting. I've never not had anyone that did not need to add the class. Anyone? Anyone? Bueller? No? Okay, fine. No one needs to add. Then that means you all met the class prerequisites. Congratulations. Okay, the College of Engineering does provide some tutoring services for our major classes. You can go ahead and check out their website if you're having difficulty with the class. The other thing you can do is talk to me during office hours. Shoot me an email. I will be happy to try and work with you to figure out how to help you in any way possible. Okay, accommodations. The Disabled Student Services, or formerly Disabled Student Services, now called the Bob Murphy Access Center, that you can find, can help. If you're having any type of learning disability or issue or need an accommodation, they are trained to deal with this and they will help you out with that. Okay, next up, I have this section in there: sexual assault, rape, dating, domestic violence, and stalking. Don't do it, please. If you or anyone you know has an issue there is some contact information here and confidential support for referrals and all of that stuff. Okay, so if you do have any type of issue related to this, there is information here on where to get some help. Food and housing assistance. One of my favorite things about Cal State Long Beach is that we are a small city, and any issue that you can think of, there's a department to help out with that, or a program of some kind. So I know when I was a student, I had a friend or two living out of their car, trying to make ends meet. This program, I believe, is set up for those people having those issues. So you can find out information here. Again, contact support or contact information for this kind of support. Okay, and that takes care of the syllabus. Do I have any final questions before I move on to lab supplies? Okay, next up, lab supplies. Can you show the link to your website again, please? Scroll up in chat. Okay, lab supplies. Okay, I'm going to keep this pretty simple and reduce it to 3 things that we need to get moving on in this class as far as the hands-on labs are concerned. The first one is going to be a free rental from the school. The NI My DAC. The NI stands for the company National Instruments. The My stands for my as in possessive me. And DAC is for data acquisition. Okay, that's where the name comes from. It looks like this. It's going to be a stand-in replacement for all lab bench test equipment. So we can create waveforms, we can view waveforms, we can create power supplies at certain voltages. That's what this guy is going to do, all of that in a convenient USB based package. You will need to get one of these. How do we get it? We're going to get it from the bookstore, but we're going to have to do something first, and that is going to be the loan agreement. Okay, let's go back to the website over here. Oh, I didn't update this one yet. I have a new version. Okay, on the website, if you go down, you're going to see a link for the equipment loan agreement. Okay, and I updated my one for 311, and I thought I had done the one for 211, but I didn't. So I'm going to go ahead and I'm going to update that. Here's where taking notes is important during the first day. Okay, I'm going to go ahead and update it to reflect the new dates, and I will email you guys when that's done. I'll be doing that right after class. Okay, what do you have to do? Let me open up the loan agreement and show you. There's only one section you need to do. Fill out the borrower. Signature. Now you can type in your name and then change the font and make it look like a signature. Or you can actually take an image of your signature and put the image onto the document. And then you can put your name, your student ID, and your date on here. Okay, so signature, name, ID, and date. I'm writing that down on my notes right now. Don't worry about filling in the serial number. Don't worry about any of this other stuff. Know that if you break it, you'll be responsible for $200. Don't worry about filling in anything else. And then turn it into a PDF and put it in the Dropbox. There's Dropbox already open for it. When? I need it by the end of next class. Okay, this ensures that if I get it by Thursday, I can submit it to the department. Somebody can then physically walk these things over from our department over to the bookstore. That means next week, you can pick them up from the bookstore and then we can get started on the labs.
Do we need an ID to pick them up?
Yes. Yeah, that's a great question. Yeah, you do. Also, wait for me for confirmation that these are actually waiting for you at the bookstore. It takes time for somebody to actually physically take it from one location to another. That person may not actually be there on Friday. If I'm getting these on Thursday and then I submit them to the secretary, she may not see it till Friday morning, at which point somebody may not take it till Tuesday. I don't know. It's a weird schedule on campus. Not everyone is there every day. So this is how we'll go ahead and handle that. Wait for me to let you know that things are good to go. And then you walk over to the bookstore during their open hours and check one of these units out. Okay? And then that will get you one of these. Awesome unit. By the way, we're going to use it in 211, 311, and personally, I wish these types of things existed when I was a student because I would have just bought one and kept it for myself and used it for all sorts of different classes because the application of, a piece of test gear like this is endless. There's so much you can do. Now, just to give you an idea of the type of person I am a very hands-on computer engineer with a passion for this stuff. Oh, I'm making the wrong picture big. My bad. Make this small. So, yeah, we got computer setup, microphone, all of that stuff. And then we get over to the electronics bench. Lots of test gear. I love working with this kind of stuff hands-on. And I do a lot of work in contracting from home, so it's useful for me to have all of my equipment available within arm's reach because I use it almost every single day. And then we get to components and stuff like that, and boxes filled with more components. The nice thing is that I can also stream any one of my devices over to the lecture and the lab when things are applicable. So I love doing that when I can just, within 5 minutes of talking about a topic that I can just like set it up and be like, oh, hey, here's what it looks like, and show you live, right? So I think test equipment is a great way to learn. And this is a piece of test equipment that actually substitutes for most things on my bench. Does it do as good of a job? No, but it is a fairly good substitute for almost all of them. So like I said, I wish this kind of crap existed when I was a student. I would have, been all over it and had one. Somebody just posted the link for it. That link is also available on the website if you're interested in one of these yourself. If purchasing yourself, here's the link, Studica. Okay. That being said, rent it for free, right? Save yourself $200. See if you like it and then buy one.
Yes, sir.
Yeah, what's up?
A few people asked before the link what happens if they don't have the ability to go onto campus to rent.
I don't know. Maybe can you have somebody else go for you? I mean, like, what's the limitation on not being able to go to campus? I think this is going to end up being individual, personalized issues. It might be a distance thing. It might be something else. Maybe we should have that conversation privately over email or privately in chat at a later time, like when class is over. Okay, so I think that's the best answer I can give for right now.
Okay, thank you.
Yeah. Sorry, I can't give sorry, I don't have a solution. I know that the bookstore is not shipping units. They didn't last semester. I don't know if that has changed. But we can look into it. Okay, what's next? We were on the topic of lab supplies. We got one down. We still have two more to go. Next up. This one is for you to buy. Multimeter. Okay, what's a multimeter? One of these little guys. Okay? It measures three main quantities that we're going to be dealing with so much in this class that we're going to be sick of it. Voltage, current, and resistance. This little guy has the ability to measure all three of these quantities. And we're going to learn about these quantities, and we're going to be looking at these quantities all semester long. Voltage, V, current, I, and resistance, R. If we are measuring voltage, we have what's called a meter of volts, or a voltmeter. If we are measuring current, current is measured in amps, then we have a meter of amps, an amp meter. And if we are measuring resistance, resistance is measured in ohms, then we have an ohm meter. And if we put all three of these together, we have a multitude of quantities to measure, then we get a multimeter. If we then attach a digital screen to the measuring of these multitude of quantities, then we have what's called a digital multimeter. If we don't have an LCD that displays the measurement of these quantities, but instead we have a needle that slides back and forth, then we have what's called an analog multimeter. See where I'm going with this? Okay, I just have to have some fun. We need to get a multimeter. We're going to be using it a lot. You're going to use it in all of your classes. My class, 311, 262, 346, 347, 447, 498, 490B, and probably a few other classes that I'm not thinking of right now. That's a lot of classes. You should have your own multimeter, and it starts here. Now let me go ahead and take you over to the best resource I've put together for multimeters. On my website, along the left-hand side, I have a page dedicated to multimeters. You can read about multimeters over here. Here's my main point. You can spend $5 for a multimeter and it'll act like a $5 multimeter. But if you spend $20 on a multimeter, you will get a good multimeter that acts like a $100 multimeter. Okay? So what I'm saying is there is a clear distinction in quality between low cost, falling apart, not good multimeter and pretty good high quality multimeter. And that price point changes at the $20 mark. Okay, so anything under 20 that looks like these, I would stay away. I give my reasons why over here. Thin wires, cables break, connections are not that good, chintzy construction, inaccurate values. Lots of reasons. For $20, I have put down two awesome options over here. One of them is the X-Tech, the little guy that I just had up on the screen. And the other one is this no-name Cronova offshore overseas budget unit that actually seems to be doing a pretty good job. And here they are side by side. Look at how cute that is. Now, I'm going to go ahead and give a demonstration between these. Now, here's the main difference. They're both the same price. One of them is non-auto ranging. The other one is auto ranging. Okay? Auto ranging, non-auto ranging. What's the difference between those two? First off, look at the dial. This one, if I want to measure voltage, I just put it at V. This one over here, if I want to measure voltage, I have 2 volts, 20 volts, 200 volts, 600 volts. Okay, I have a range that I need to be aware of and select the correct one. I also have one for 200 millivolts. I'm going to stick this at 2 volts, and I'm going to stick this one at just V. And then I'm going to take a voltage source. In other words, I'm going to take a little power supply right over here. And I'm going to go ahead and connect that, and then I'll show you the voltage. So this is just like a power supply that you would use to charge a phone or a laptop, except that I can change the value. I saw a question in chat. I will answer that afterwards. All right, so I hooked up the probes of both multimeters to my voltage positive, and I hooked up the other probe to voltage minus. We will learn about that. I just want to show you the difference so that you can make an educated decision on what you're going to buy. Right now, my power supply is set at 1.28 volts. I can adjust my power supply. I'm going to start moving it up. All right, we're at 1.5 volts. We're at 1.7 volts. We are at 1.9 volts. And this multimeter stopped measuring. This one is continuing. 2 volts, 3 volts, 4 volts, 5 volts, and it'll keep going up. Notice this is still on V, whereas this one is on 2 volts. And notice that this multimeter on the left is only working when I'm below 2 volts, right? 1.9 volts, 2. Okay, we stopped measuring. But if I change the range, if I manually adjust the range, now, oh, we were at 3 volts, 4 volts, 5 volts. Right? All the way up to 20 volts, at which point I will have to change the range again. So what does that mean? I got to constantly fiddle with this and change the range for the value of measurement. Now, I think that's kind of cool because I have to have an idea of the voltages I'm working with in the first place. In my opinion, it makes no difference whether you have this one or this one. I've used both. I've even used analog meters before when I was much younger. Now somebody asked, it looks like this is clearly superior in every way because it's auto ranging. Why would I ever want this one if this one requires less fiddling with the buttons in order to take a measurement? Well, here's the thing. This is a no-name brand. I don't know about its quality, its durability. I don't know how long it's going to hold up for. I know X-Tech's a good brand. I've been using this guy for a while. Not only that, I know that his measurements are a little more accurate than this one's measurements. In fact, I made a video about it, and you can check out my $100 workbench video on the web page, and you'll see that I do a comparison of these guys. I plotted out on a spreadsheet. Turns out this X-Tech is awesome at getting the voltage measurement very precise and spot on. Is it enough to say that this one is better than this one because it's more accurate with the numbers that it's measuring? No, because it's still very close. It is a very subtle difference in accuracy, not one that I think should concern anyone. So, judging by that, it does appear like this is better value for the dollar than this one. But I just want everyone to be aware that there is a quality, there has to be a quality difference between these two because these are the same price, yet this one has a lot more functionality as far as the auto ranging. Now, if you want the brand name in auto ranging, go back over here. There's a $50 one that is auto ranging. It's made by X-Tech. This is an awesome multimeter too. If you're curious what I use at home, I use more of the industrial multimeters made by Amprobe. I like my Amprobe multimeters, but they do cost a bit more. Now, what do I use at work? At work, I use multimeters that have been calibrated, and those are $300 to $500 multimeters. Okay, there's no reason to go above 100. There's no reason to even go above 50, and I would say 20, $23, $24 is the right price that I don't think you're throwing money away by getting any of these units that I've suggested. Okay, I think these units are a waste of money. I think you're throwing away $5, $10, $2. You can even get a free coupon for this one on the left. I think that's still too much for it, in my opinion. So that's as much as I'm going to talk about for multimeters today. It's quite a bit that I feel like I've already talked about. You will need a multimeter. You will need it by week 3. Okay, so we got 2 things already. Both of them have been test equipment. Multimeter, 20 something bucks, free. But we need a breadboard, we need some electronic components, we need a bunch of stuff. Okay, next up, this is not the end-all be-all for electronic components, I promise you. There's a reason I have a ton of stuff on my desk. But this is a good way to get started. It's an electronics component fun kit. What can go wrong? We got some wires. We got some other wires. I prefer these wires. I'll tell you why. These wires don't have a habit of breaking like these wires do. These wires break all the time. I have students like debugging their stuff for hours. And when I see it, I'm like, it looks like something here is not right. Let me measure this. Let me check this. And I'm good with my troubleshooting skills. So I find the wire pretty quickly, usually a couple of minutes. But that being said, to someone who does not have 15 years of experience tracing and debugging these types of things, it can be very frustrating to have a broken wire and not know about it. I've seen these types of wires actually just broken right out of the package. They're cool because they're like ready to use and they go into our breadboards like this. Get in there. Like that, but I just find that the connection's not as good. What I love is that these wires are bulletproof. Like, how can this go wrong? It is straight up metal attached to metal. Put that in there, we got a good connection, okay? So we're gonna be constructing our circuits on a breadboard using some wire with some components like resistors and capacitors and LEDs and chips. And it comes with some prototype boards for soldering stuff. There is no requirement to solder. If you're curious what soldering is, it's the joining of these 2 connections using liquid lead. It's fun. And I do a lot of soldering myself, a lot of soldering myself and reworking and stuff like that. And I'm happy to talk your ear about it, about soldering. But with this online at home, there's no need for that. Okay, is it the same kit for 262? No, this is a different kit. Okay, where is the link for this kit? Website. Go back to the 211 page. Scroll down. Here we go. Basic electronics part kit from Amazon. Please take notes on this so that I don't have to repeat. Okay, so those are the three things that will get us started. Like I said, it's not the end-all be-all of electronic components, and it's missing some stuff. But you know what? Let me click on this link. For 18 bucks, it's a lot. Okay? A lot of cool stuff in here for 18 bucks. So realistically, we're looking at about $40 of your own expense. And, you know, how much does a book cost? This is less than $1. And you're getting a lot of functionality at your desk for 40 bucks. The wires that I prefer actually come with it, so that's kind of cool. Okay. So we are already at 11. What time is this class over at? $11:45. I really don't want to lose 45 minutes here. Let's take a 5-minute break. Does everyone need a 10-minute break? Okay, 10-minute break. Now, we'll be back at 11:05. Sorry for going over on time.
Professor?
Yes.
So,
And this Greek philosopher named Democritus was sitting there pondering the nature of matter around us. And I like to think he was perched on some rock with a big flowy beard of sorts, just like every good Greek philosopher would look like. And he was thinking to himself, I wonder if I take this object, let's just say it's a rock, and I go ahead and I break the rock into two. Now I got two pieces. I take one of the pieces, throw it off to the side. I take the piece that's remaining and I go, let me take this piece. Let me break that in half. All right, I discard one of them. I take one. Okay, I break that in half. I keep on doing this. He goes, is that ever going to stop? And he said, it's got to. At some point, I cannot further divide this rock. It must be made of some fundamental thing. And he named this the atom, if he spoke English. He didn't. He spoke Greek, so he called it atomos. Okay, so that's where we get the atom from, or at least that's where we get the name from. Fast forward 2,500 years into the early 1900s, around 1913, turns out he was not far from the truth. Now, obviously, we know from, atomic explosions, nuclear weapons, we know that you can split the atom. But that being said, not under normal situations, right? Okay, so now we get to modern times, about 1913, with a gentleman by the name of Niels Bohr. Now, he was a Danish physicist. Amazing gentleman. Go look up his track record. And he developed the first useful model of the atom in 1913. To say that this guy was a great and a giant is, it's an understatement. This guy's amazing. I mean, quantum theory, all of modern physicists really owes itself to this guy. Really, go look him up. Okay, this whole thing of him developing the first useful model of the atom, that's like a drop in a bucket compared to all the other things he did. And you may be familiar with this model. It's what we know from high school. It's what we know from grade school, right? I shouldn't even say high school. We got some protons and some neutrons in the center of the atom. I will do proton. With red, and I'm going to denote it with a positive because we say that this has positive charge. And it lives in the center of the atom with its no charge companion called the neutron. And orbiting around the nucleus is the negative charged electron. Okay. Now, we say that the protons got positive charge. We say that the electrons got negative charge. Positive, negative, arbitrary naming convention. We could just be that the electron's considered positive, the proton's considered negative. Their opposite is what this is saying, right? Okay. But we, by convention, will say that this is positive, and we will say that this is negative. And it is useful for us when discussing this basic electron theory and eventually the first electrical circuits that we're going to look at to be able to figure out the organization of this structure of the atom that developed by Niels Bohr in 1913. This is a pretty good depiction of what's going on. It is not the end-all be-all. There is more accurate than this where you have electron clouds and all sorts of things going on. But that being said, this is a really good model that works, so we're sticking with it. Okay. So how do we talk about the organization of this structure? Well, we're going to need a couple of rules. Rule number one. The number of electrons equals the number of protons. I'm going to write this on another paper. All right, that's all there is to it. If I tell you that an atom has 10 protons, how many electrons does it have? 10, okay? It's always going to have the same number of electrons as the same number of protons if the atom is balanced, and we're going to assume that it starts out that way. We will talk about imbalancing these these atoms later. Okay, but if you go ahead and look at the periodic table of elements, you'll notice that the number of protons is always listed at the top of the atom in question, okay? And so this is how it's organized by weight, because it turns out that that's what gives it its mass. So we know that if we got one proton in hydrogen, then we should have one electron. Similarly, for lithium, we have 3, we should have 3. If you're looking at copper's the fun one, then we have 29. I say copper's the fun one for us. So let's go ahead and let's talk about copper. Copper has 29 protons. Therefore, how many electrons does it have? Chat.
29.
It's got 29 E's, right? E to the minus, because it's negative electron charge, negative charged electron. Okay, so 29 E's. Now, I'm not going to sit there and draw 29 little circles, so what I'm going to say is 29 atoms, and I don't care about the neutrons. Sorry, not 29 atoms, dear. 29 protons, and I don't care about the neutrons in the nucleus. The nucleus has 29 protons, that's all I care about. And it's got 29 E's that are going to be orbiting around this. So we got to talk about how that gets organized. All right, well, rule number 1 did not help us out with that organization of the electrons. So we need another rule. Okay, the max number of electrons in shell equals 2n to the square. All right, so max number of E's in shell. What is shell? What is shell? Okay, as it turns out, they are not going to all orbit the same orbit. There are different orbits further out. So we're going to actually end up with, and you'll see why in a minute, we're going to end up with 4 shells. Okay, now you can't put 29 into one shell and 1 into another shell, or 28 in here and 1 over here. There's method to the madness. Follows this little equation. So let's go ahead and let's talk about our shells. In fact, I'm going to set up a table. Shell number, starting from the inside, working your way out, it's going to be 1, 2, 3, 4. Now, each one of these shells has a max number of electrons that it could hold. For our first shell, it is going to be 2 times 1 to the 2. 1 squared is 1 times 2 is 2. So 2 is the max number of E's that can be held in shell 1. Keep in mind, this is max. It doesn't mean that there's actually 2 electrons in here. It just means that this shell number could hold, at most, max 2. All right, let's do the same for 2, 3, and 4. 2 times 2 raised to the 2. 2 to the raised to the 2 is 4 times 2, 8. And so forth. Okay. We got to stuff 29 electrons into these shells, following that these shells can only hold a max number of 2 for the first shell, 8 for the next one. So out of these 29 electrons, the first shell is holding 2 of these 29s. 1, 2. So let's say the number of E's in shell for copper. That first shell, 2. It's got 2 electrons. Okay, what about the remaining electrons that we have to stuff into these other shells? Let's go ahead and set up another column for that. Remaining is going to be 29 minus 2. All right, let's go on to the next shell. We got 27 electrons remaining that we have to stuff into these next shells. The shell number 2 can only hold a max of 8. So out of the 27, 8 of them will go here. That's going to look like 1, 2, 3, 4, 5, 6, 7, and 8. All right, let's keep going. 27 minus 8 gives us 19 remaining electrons. All right, we got 19. We got to stuff into 3 and 4. However, 3 can only hold 18. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Well, how many remaining electrons do we have to fit into the next shells? One. Okay. The last shell can hold up to 32, but it only needs to hold 1. Because we had 1 remaining. That means that this outermost shell's got 1 electron hanging out by itself. Now, electrons in the outermost shell are referred to as valence electrons. We care about the number of valence electrons because the valence electrons are the most weakly bound electrons to the atom. So let me go ahead and define valence electrons. Okay, so valence electrons are the electrons in the outermost shell. These are not as strongly bound as the rest of these electrons, which means these can be taken away, these can be given. Okay, it always happens here at the outermost shell. That's going to end up being incredibly useful and valuable for us. Now, as it turns out, not just are the valence electrons the ones that are easy to take away or to give, but the number that we have in the outermost shell, the number of valence electrons, actually determines how easy it is to take them away and give them. Easiest way to show you this is a graph, table, line drawing. Number of valence E's. We could have 1. All the way to 8. In other words, we could have 1 electron here and we could go all the way up to 8. We could have 1, 2, 3, 4, 5, 6, 7, 8. That determines how easy it is to take away this electron or to give it an extra electron. In other words, if we have fewer, this is unstable. And the more that we have all the way up to 8 means we have a very stable atom, one that does not want to give or receive valence electrons. The result of this is that the very unstable, the one that we can take away an electron and give it another electron, and we can kind of keep on passing the electron back and forth, this is conductive. And the one that is very stable, that I can't easily give it an electron or take away one of these valence electrons, is a very poor conductor. It's an insulator. So what does this mean? Well, now you know why copper is a good conductor. It's because it's got only 1 valence electron, and the fewer valence electrons we have, the easier it is to pick them, take them away and give it more. However, plastic, glass, things that are not metal, rubber, those are all very stable, poor conductors with about 8 electrons in its outermost shell. What's the best conductor? Go ahead and put that in chat. What's the best conductor out there? Gold. 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 Gold? And 1 silver. Gold is not the best conductor. Silver is. But wait, my audiophile connections from my $1 million vacuum tube receiver with the Wi-Fi's and stuff, that's got gold connections. Isn't gold the best conductor? Why do you think they like to use gold for connections? when you could just use the best conductor, which is silver? What does gold not do that silver does? Gold resists oxidation. Exactly. Okay. Silver tarnishes, silver rusts, silver oxides, which makes for a terrible connection. I don't want rusty connections. So for connectors, people love gold because it doesn't tarnish, it doesn't oxidize, there's no rusting involved there, right? So that's why you're going to see connections being made with gold. But in a non-oxygen environment, you are much better off with silver, because silver actually is a little better of a conductor than gold is. Okay, so that's my my fun with conductive metals. Now I have another question. What if I have 4 electrons? I'm not a good conductor, but I'm not a bad conductor. I'm a semiconductor, right? I'm not bitter chocolate. I'm not sweet chocolate. I'm semi-chocolate. Wait, semi-sweet. That's what I meant. Okay, semiconductor. Okay, this is silicon, germanium, all of that cool stuff that we have for making transistors and diodes and all sorts of active components that we will learn about next semester. Or at the tail end of this semester. Okay, so that is it for my electron theory. No, there's a little more, sorry. All right, I can also actually do the action of taking away this electron or giving it that valence electron. So let's go ahead, let's do that. I can take this hydrogen, I can give it an extra valence electron. If I do that, I have made this more negative. In other words, I've made this more negative, right? Because it's, I got 2 electrons and 1 proton. These 2 cancel each other out. I'm left with more negative. So we got a negative ion. I could also do the opposite to this little hydrogen over here, this poor thing. It's already got so little. I'm going to take even more away from it. I'm going to take away an electron. And I'm going to be left with just a proton. Wah, wah, wah. Okay, now since I took away the electron, I'm left with something that's just got 1 proton, so 1 positive. This is a positive ion. Okay, this process of taking away or adding these valence electrons is referred to as the process of ionization. And we care about this because it alters the balance of charge. More negative, more positive. We have balanced over here. Then we get positive if we remove an electron, and we get negative if we add an electron, okay? And keep in mind, these electrons that we are giving and taking can only occur in that valence outermost shell. Okay, these are valence electrons that we are willy-nilly taking away or adding to it. Okay, how do we do this? How do we cause ionization to happen? There are a few different ways to do this, and they all involve imparting energy on the material. Okay, a few different ways we can do this. First off is with chemical energy. Think of batteries, okay? Batteries are chemically induced little cells that already have a situation where you have more positive on one side and more negative on the other side, creating a situation where the electrons want to go back and mingle so that they can be positive, or so that they can be balanced again. Okay, that's chemical energy. So chemical energy, I can go ahead and create this ionized situation. Mechanical energy. Think of a generator. I can take a magnet, I can wave it over some wire, and I can go ahead and cause electrons to move away from one material into another one. Okay, so that again can cause this process of ionization. Okay, there's another one. I'm going to use this example today: friction. Static electricity. Let's see. Can I get this balloon to stick to my head? Right? Cover up that bald spot on my head. I'm getting old. Okay, what just happened? I rubbed a balloon against my head and it got stuck to my head. Why? Well, first, let's take the professor's bald head. I look like Krusty the Clown. Okay, and in my head, in my hair, I have a balanced situation. I have one negative for every positive. All right, the same is true for this balloon. All right, what just happened? I rubbed the two together, and because of friction, energy going into the system caused electrons to fly from the balloon and actually deposit themselves into my hair. Okay, so now I have more electrons over here and less electrons over here. What just happened? I lost electrons. This became more what? Say it in chat. And this became what? Say that in chat. And what do positives and negatives like to do to each other? Attraction. They attract. Okay, this falls under the basic law of charges. Opposites attract, like repel. Okay, that's your basic law of charges. I got 3 minutes left. We have a little more fun to do. Okay, let's go ahead and let's talk about what we're gonna see with this apparatus that I just brought out here. This is known as an electroscope. I have a jar with a conductor running down the center of it. At the bottom are 2 foil leaves that can freely move. It is constructed of some conductor. Let's just say it's got 1 valence electron, and it is currently balanced. Now, what happens if I take that balloon that I ripped away the electrons from, right? They went from the balloon to my head, and I take that balloon that is now positively charged and I physically move it close, but not touching to the top over here. What is going to happen to this positive and negative charge in here? Say what you think's going to happen. Yeah, Matt's got it. Positive is going to attract the negative. The negatives are going to freely move up, and they're going to collect up here. So we get electrons that move from the bottom to the top. That means the bottom 2 foil leaves remained more positive. And these foil leaves are free to move around. So now I got 2 freely moving foil leaves that are both positive. What are they going to do? They are going to repel each other. All right, let's see if this happens. Sorry, close your eyes if you get dizzy and motion sick. What just happened? Why did my... I lost my face camera. Let's go with something kind of like a black background here. All right. All right, that kind of works. There's a little bit of a reflection. That's okay. We can live with it. Let's go this way. I kind of want to get both. Okay, that's good enough. Why did I lose this? Okay, I think I can be back online in a second. Sorry, I got too many cameras around here. I know we're 3 minutes over. I'm going to be done in 30 seconds here. Okay, we're back up on it. However, instead of using the balloon in the head, I'm going to use a plastic ruler and fur to get the same effect. So what I'm going to do here is I'm going to go ahead and impart some energy, put some friction into this thing. And now electrons are coming off of the ruler and they're going into the fur. And now I have a positively charged ruler. Let's go ahead and let's bring it close to the electroscope. I hope this works. Ah! Not bad, right? No tricks. This isn't a free energy device on YouTube. No motors in the background. The foil leaves, or the thing that's kind of like a foil leaf, is repelling the other one and moving away. Right? Okay. Not wizardry. It's basic law of charges and energy and atomic theory and everything that we talked about thus far. Okay? Is that good enough? Can I get an ooh, an ah, I can't see. I don't know if people are impressed or not, or just everyone's like, all right. That's rad. Thanks, Aiden. Okay, sweet. That is it for today. I'm sorry I went a little over in time. We had so much to do, so much to talk about. Please get that loan agreement. Remember, I will send an email about updating the loan agreement. There's all that stuff. You should have taken notes on it because I don't remember things anymore. And I will see you guys on Thursday. Stick around if you have any, private messages for me. And you're always welcome to email me. And aside from that, I will see you guys later. I was in shock. Didn't know what to say. Thanks, guys. Yeah, thanks. I appreciate it. Thanks for hanging around. I know it was a lot to cover today. I appreciate the patience and the note-taking.
Thank you.
Will any of the lectures be recorded? Okay, so to address that question, the recordings from previous semesters are already available on the website, and believe me, it was a ton of work. However, there are key lectures that I will be re-recording, things that I personally want to make better, things that I want to improve, and then put them on the website. There is no guarantee that the lecture that you want is going to be uploaded and new.